Hi guys, we're going to go ahead and start our last unit of the year. That's new material that will be on the AP test. So because of 2020, they shortened the curriculum. Now, if you're not AP testing, then starting next week, while AP testers will start doing review material from first semester, non-AP testers will continue to learn the material that the College Board took out of the curriculum to be tested. And there is an important reason for that, because the two units that were taken out of the curriculum, one is very important if you end up taking a biology class in college, and the other unit is very important for any business courses and science courses as well. So that because of that, then I want to make sure that I'm still exposing you to that curriculum so you're not missing out. All right. So here's our last unit for AP testing. So simulations is a situation where we want to simulate an event and determine a probability, a proportion, or come up with an expected value, an average. Okay? Remember, our expected value is the mean. Expected value is the mean. Geometric 1 over p, binomial n times p. All right, and in fact, we typically use simulations when the scenario is something we want to estimate, and it's a more complex situation than just those simple geometric and binomial probabilities that we learned back in December. Okay, so it is important when we do a simulation that we do identify certain criteria that we have to cover and certain steps. And that is important so that all of those are there. The idea is somebody should be able to follow your steps exactly and reproduce similar results given another set of randomly generated numbers. All right, so because of that, then I have a mnemonic device to help us with it, and that is this thing called ELARSA. Okay, it's kind of like when we did our experimental design, we did SREP me capped, SREP me capped. Okay, ELARSA is going to be the mnemonic device to help us with simulations. And of course, then there's a song to go along with it. Not quite as catchy as our SREP me cap. And it just goes to Twinkle, Twinkle, Little Star. So it starts out talking about what each digit will represent and what we will let those numbers be. So let's start talking about just those two items and talk about how to set up a real-world scenario mathematically. Okay? So we'll come back to the rest of those words after we go over this. So let's suppose one of my students misses free throws in basketball just 20% of the time. Okay, some of my basketball guys just miss it 20% of the time. So how could we use digits to represent proportions or percentages such as 20%? Okay, keep in mind we could do like 10%, 20%, 30%, 40%. So because those are in the tens place, and 10, 20, 30, 40, 50, 60, all the way up to 100% could be represented each by one of the 10 single-digit numbers, then this is a situation where we could use one-digit numbers. Okay? You could do two-digit numbers, but it's not necessary. And so as we get into this, then you'll see one-digit numbers because, percentages, the 10%, 20%, and so on can be represented with just 10 single digits. Okay, with 10 single digits. All right, so how then could we maybe represent a 20%? What digits could we use to represent? So let's let these numbers be what? Here's an example. We could say, and I usually like to start with 1 and 2, and those were the missing, the shots missed. Okay? So if 1 and 2 are going to be the shots missed, then what would be the digits to represent making it? So then that would mean that numbers 3 through 9, keep in mind, 3, 4, 5, 6, 7, 8, 9 is only 7 digits. Where's that 8th one for the 80% of the time you make it? What's the single digit missing? And that is the 0. In simulations, I typically think of the 0 as the 10th one, or the double 0 as the 100th one. Okay? But there is another way you could do this. You could, sometimes people do this. Let 0 and 1 equal a miss. And so then that would make your 3 through 9. Oh, wait, sorry, 2 through 9. So that would be our 2 through 9 be make. Okay, and so then that would be counting for all those 10 digits. You could pick any digits. You could say, let 9 and 0 be a miss, or whatever. Okay, pick 2 to miss and the 8 to make. All right, but what if, this is more likely something that I would experience if I am missing it, not 20% of the time, 78% of the time. What kind of digits then do we need to use to represent numerical values that have to be more precise, not just 10, 20, 30, 40, 50? And I stop here. I wrote 1 digit, 2 digit, but we could do 3-digit numbers and so on, depending on how many different values we have. Well, I hope you can see that when we need to be more accurate, then we need more digits to represent those accuracies. So we do, in this case, need to be 2-digit numbers to be accurate, 2-digit numbers to be accurate and more precise to the ones place. We're not just doing it to the tens digit. All right. So how could I represent 78% of my free throws are missing? So that was each 2-digit number would represent a free throw. And let's start with, how would I make the number 1 a 2-digit number? Okay? Because I cannot just say, oh, look at a whole bunch of numbers and you have 1, 2, 3, 4. Well, those are single digits. I need everything represented as 2-digit numbers. So 1 as a 2-digit number would be 0, 1. So I'm going to let 0, 1 to 78 equal a miss. Okay, and then let's do the other ones. So if I did 79 to 99, that is actually 21 items. I need the 22nd item. Is that how that works? So what is the 100th piece of data in 2-digit format? That would be 00. Okay, so those would represent making it. Now, some people might want to do it differently. Some people could say, let 00 to 77 equal a miss, and then 78 to 99. Now that's a make, okay? Doesn't matter. You have options. You can do things differently. All right. So that's the deciding what kind of digits we need to use, 1 digit, 2 digits, 3 digits, and so on, and how we could use the proportionality to have particular digits assigned to an event of making or missing. So here we go. Let's take a look at our first example here. We have got 9 sales representatives at this small company, and there are 6 men and 3 women that are the sales representatives, and they want to attend this national convention. So there were only enough travel funds to send 3 people. Okay, so you're going to put all of their names in a big bag, shake well, and pull out 3 people's names. Well, the manager selected 3 people to attend and stated that they were selected at random. So everybody had an equally likely chance. All samples, all the different types of samples of the different type of people had an equal chance of being chosen, all the different samples of size 3. The 3 people selected in this case, however, were all women. So some people got suspicious. They thought, there are 6 men and none of them were chosen. 2/3 were men and no men were chosen. So they were concerned that maybe it wasn't done completely properly randomly. So describe and conduct a simulation with 10 trials to estimate this probability that all 3 of these representatives chosen are women. Okay, so let's see what that happens. So we're going to use this random number table down there at the bottom and indicate our methods clearly. Now, before we get into that, I want to talk about how this would work theoretically. So where's kind of our target? We know in the long run it should end up somewhere around what it's quote unquote supposed to be. How likely is it that if you picked 3 people, they would be all women? Well, we did that last fall. And we did that where we would say, okay, we need to have the first person be a woman, and the second person be a woman, and the third person be a woman. Okay, so how could we do that? If I had everybody in a bag, shake well, what's the probability the first person I pick out is a woman? Okay, and then that's going to be 3 women out of the 9 people in the bag. So 3 9s. All right. And I need the second one to be a woman. And there's 2 left in there that are women out of the 8 people in the bag. Because once I pick that person, they can't be chosen again. I do not put them back into the bag, so the probability is changing. Okay. And then the third one to be a woman, there's 1 left in there out of 7 people in the bag. So if I multiply that out, it's like 0.0119, something like that. So there's only about a 1.2% chance that if all samples of size 3 are equally likely to be chosen, there's only 1.2% chance that I would have gotten all 3 of them being the women. So what do you think about that likelihood? 1.2% chance of getting that sample out of all the possibilities. What does that sound like if we have, the null hypothesis says all samples of size 3 are equally likely, are equally likely to be chosen. So they are doing, they are equally likely to be chosen. And so, meaning there was just pure randomness. Okay, well, that's the null hypothesis. But guess what? There was only like a 1.2% chance that we would have gotten that type of sample over there. What is this called? 1.2%? That is, hopefully, this kind of is connecting to what we just finished. There's just a 1.2% chance of that happening, if indeed all the null hypothesis is true. So that p-value is the probability of getting that particular sample, or more extreme results, which I don't know exactly, that's kind of like the most extreme one, if indeed all samples are equally likely to be chosen. Okay, so what would we end up doing with that p-value of 1.012? We would probably end up rejecting the null. So we think, and we have statistical evidence to suspect some foul play and think that they were not chosen properly. All right, here we go. So here's the song over here. And we're going to start with, Each digit represents, let the numbers be. So that's our two parts of the first of the song. So if I have these 9 people, how do I want to represent them with digits? I just need to have 9 people in the bag. How can I do that? Well, if I use 1-digit numbers, there's 10 to choose from. So I could do that and then just maybe ignore one of the digits. So let's do that. So each 1-digit number represents a sales rep at this company. All right. Each digit represents, let the numbers be. Okay, so let's see what we want our numbers to be. What do you want to equal the men? Okay, I'm going to say 1 to 6 equal a man. Okay, and then numbers 7, 8, and 9 equal a woman, or the women. Okay, and how do I address the fact that there's another digit I don't have accounted for here? I'm going to note that I'm going to ignore the digit 0. I'll just pretend like that's not even part of the mix. Okay, ignore zeros. Good, so each digit represents, let the numbers be. Use a random number table, start here please. So we're going to use that random number table that is at the bottom of the page and start at the top left corner. Now, you could start the bottom right-hand corner. You could start at the top right-hand corner. I don't care where you start. Just explain where you start so that somebody could follow along with exactly how you carried out your simulation. So, use a random number table. Use a random number table below and start at the top left corner. That's where I pretty much always do this. All right. Each digit represents, let the numbers be. Use a random number table, start here please. Okay, here's the next one. A trial consists of, what do you ignore? Okay, so when we perform a simulation, we do multiple simulations. If you have a computer-generated simulation, there will be thousands upon thousands of simulations. A lot of times they run that because they know then, according to the law of large numbers, the more simulations you run, the more experimental will go and be close to the true probability. All right, so let's take a look down here. These first problems we're going to have in our first set of notes are going to be ones where the trials and the response and the statistics are like this. So I'm going to call these notes part 1, these ones that have this scenario like option 1 here. And these are ones where you have a set number of items that you need to look at, and that's the end of a trial. For example, we're selecting 3 people to go on the trip. Bam. Once 3 people are selected, that trial is done. Okay? Another example might be you pick 4 coins and you're going to see what the results of those 4 coin flips are. So pick 4 coins, done. That's the end of the trial. Pick 4 coins, done. Pick 4 coins, done. And so on. Okay? You have enough money to look through 5 cereal boxes. So you go through 5 cereal, or you buy 5 Happy Meals, whatever, and you're trying to get a certain prize you want. Okay, so that's what we have going on here. A trial consists of, what do you ignore? So when we have this what do you ignore, that's where we usually address repeats, and it's just kind of a reminder where, was there any digits we needed to ignore? Well, we already addressed that here. Okay, so we kind of already did part of it there. That's just another check to make sure you're covering all your bases. All right, so a trial consists of picking 3 people to go on the trip. A trial consists of picking 3 sales reps to go on the trip. So, for example, let's go ahead and take a look down here at this random number table and see how this is going to kind of work. So we have this random number table. These numbers are clustered into chunks of 5 just for the ease of your eyes. Because when you have just a continuous number, it actually is pretty difficult and your eyes kind of go crazy. So if for example, we were doing 2-digit numbers and you ended up having a 2-digit number that crossed over that gap, and in this case it was 43, that can happen. Okay, the 5 chunks of 5 are just for ease of your eyes. Consider it a continuous list of numbers. All right, but we're doing 1-digit numbers, so here we go. So this first number I come to is a man. So, oh, I just said it. That's a man because I said numbers 1 through 6. Okay, so that man, sales rep number 1, ding, 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 you won. You get to go on the trip to the national convention. Okay, so what happens here? Now we pick this person right here, this number 1. Well, wait a second. That person, sales rep 1, is already going on this trip. That person can't go again. I mean, I need to pick 3 different people. So what should we do to address a situation when there's a repeated number, but that person can't go on the trip again? See, once I pick this first number 1, now there's only 5 men to select from, so that probability is changing. So because the probability is changing, then, and we saw that when we did our little theoretical one up here, the probability 3/9 and then 2/8 and 1/7. So because that probability is changing, then we're addressing that with, no repeats. So we will actually ignore the repeats in this case, okay? And so we are going to ignore the repeats because each person can only be selected once. And once they're done being selected, they're done. They cannot go back in the bag. Okay, so for example, we say, oh, okay, no number 1 and no number 1 there. Up, and then here we got a number 6. Okay, what gender is that? That's also a man. And then we have this one, number 4. That's also a man. Stop. That's the end of the trial. We have now just selected 3 people to go to the convention, and they happen to be all 3 males. Okay? Now, that's the end of the trial. Okay? So we're going to start again and simulate another trial. So everybody's back in the bag. Shake well, and here we go again. Okay? This first person, number 3, ding, 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 you get to go. You are a man. Number 6, you get to go. You're a man. Number 3, sorry, you've already been selected. You can't, so I have to ignore a repeat. And then number 1, once again, you're a man. So done. So there, right there, I had 3 men chosen in the first simulation, in the first trial, 3 men chosen in the second trial, and so on. So what I want you to do is pause this video real quickly, and then I want you to carry out 8 more trials and define, what you get in those: man, man, woman, woman, man, whatever. Okay, so pause the video now and then carry that out. All right. So I have done my work there, and I have completed those 10 trials, and I wrote them out. I had to catch myself because I forgot that, like, the zeros, I had to go back there and cancel out the zeros because I forgot those. I had to ignore. I was thinking those were women. But anyway, so I'm going to go ahead and so I've listed them all as man, woman, or woman. Okay, so let's continue. So up here, we've done all of our trials. Now, so a trial consists of what do you ignore? Or your response is critical. What will you look for? So besides looking for defining them as men or women, okay, then let's take a look at this information here. So the response we have at the end of each trial is not just who went, man, man, woman. Remember that our original question was to estimate this probability that all three of the representatives chosen are women. Okay? And so we want to estimate that probability that all three of the representatives chosen are women. So therefore, when we take a look at this response we're going to write about, then what we are going to say ultimately is yes or no, I got what I was looking for. So, for example, yes or no, did you get all three women? Yes or no, you got exactly 2 heads and 2 tails. Yes or no, you got the prize you were looking for. Okay, so yes or no, did that occur? And so let's actually just put yes or no on these items here. In fact, I think I had none of these. I had several that had 3 men. I had a couple of them that had 2 women. I think 2 of them had 2 women, but none of my trials had all 3 women. Okay? So that means that I define my response. So my response is yes or no to if all 3 chosen sales reps are women. Okay, so there we go. A trial consists of what do you ignore? Your response is critical. What do you look for? Okay, so now we're going to finish this song out. Get your statistic, man, 'cause I want to know, according to your simulation, about what does this show. So let's finish this up and get our statistic. So down here I have listed the statistic in these questions that we are looking for is that proportion of times we got what we wanted. Okay, so one of the keys to knowing what kind of problem is this and what, my process, one of the keys of knowing I'm following this option 1 content is that it asked me to estimate the probability or what is the chance. Okay, if it had said what's the estimate the average number of things, that's a different process, and we're going to cover that in notes 2. So these all say estimate the proportion or estimate the probability or what is the chance that that occurs. So that means our statistic is going to come from the proportion of times we got what we were looking for out of that total number of trials. So in our case, our statistic that we got was 0 out of 10. 0 out of 10 were all 3 women, so that's a 0% chance. So, according to your simulation, about, what does this show? Don't forget to talk about. So, according to my simulation, I expect to get all 3 women chosen about 0% of the time. Okay, and let's think about this. With having 10 trials, I could just have 0 as my answer, 0, 10, 20, 30, 40% of the time. And so what do you have to say about the results of this simulation and the theoretical amount up here that we anticipated expecting? That's as close as I could have gotten. Okay? In fact, if we did many, many trials, if we did many more trials, then guess what that cumulative probability would do? It would settle down to that 1.2%. Okay, what is that called if you do many trials, many trials? The cumulative probability. It will settle down to the true probability. The law of large numbers, you see. Okay, so that if we did many more trials would settle down to about 1.2%. Okay? All right, let's take a look at the next problem. So the next one says, what is the probability for finding 2 heads and 2 tails? So we want exactly 2 heads and 2 tails if we toss 4 coins, or we toss this particular coin 4 times. Okay? Now, the catch is that this coin is not a fair coin. In fact, the coin will land on heads 55% of the time. Okay? So describe and conduct a simulation with 10 trials to estimate a probability for finding this exactly 2 heads and exactly 2 tails out of 4 coin tosses. All right? And use the random number table below and mark your stuff. So before we start, I actually want to kind of review back to, because this one we can represent theoretically as well. Now these first 2 problems, I picked ones that we actually could do with mathematics that we learned back earlier in the year so that we could see theoretically what the probability is and then look at our results and see how our experimental results compared to theoretically what should happen. Okay? In the real world, though, we typically would not go through the process of doing all this simulation stuff if we could do it theoretically. Okay, so this is one. So in the future, I mean, they'll be more complex where we wouldn't necessarily be able to confirm with a theoretical. All right, in real life. So we want to find 2 heads and 2 tails. We know that the probability of heads is 55% or 0.55. Okay. Now, we actually did problems like this back in December where we would say you flip 4 coins and then I want to see exactly 2 of them are heads. Well, the issue that we came across was that those 2 heads could be sprinkled in many different combinations. They could be the first and second, the first and third, the first and fourth, and so on. So we ended up having all these different combinations this way in which out of 4 you could have exactly 2 heads. Do you remember how we did it with those kind of problems? Those were the binomial kind. So we'll just do a quick review of that. If I want to say I want exactly 2 heads, okay, X is the heads, then let's, and not that I expect that you have this memorized, it is on the formula chart, but you remember 4 choose 2 successes, and that was like a big old factorial mess of mathematics that our calculator would do for us. So 4 choose 2, and then let's see, then we have the successes, and 55% of the time we will get heads, and I want 2 of those to be heads, okay? Which would mean 45% of the time we would get tails, and if you have 2 heads, then we're going to have 2 tails, okay? Now, that's a binomial problem. Would we do this with binomial CDF for a cumulative amount, or would we do this binomial PDF for a particular exact amount? And that is binomial PDF is how we would have done this one. And we would have had, out of 4 trials, 55% chance of heads, and I want 2 of those. And so then that comes out to 36.3675, so about 36.75% chance that if I flip this particular unfair coin 4 times, there's about a 36.75% I'll get 2 heads and 2 tails. All right, so let's see how our simulation comes out in comparison to that, theoretically, what it should we expect it to. So here we go. Our first situation, each digit represents, let the numbers be. Okay, so this is based on the kind of probabilities we need to represent. And I have this 55% situation. So can I represent 55% with, say, odds or evens? Odds or evens are going to be 50-50, 50-50, not 55. Could I represent 55% with just using one-digit numbers? One digits would just be 10 options, so that would just be 10, 20, 30, 40, 50. So no, I need to be more precise to the ones place. Therefore, I need to use two-digit numbers. So each two-digit number represents, and what is this that we're having them represent? A coin toss, or the result of a coin toss, whichever you could say, same thing. The result of a coin toss with this particular unfair coin. All right, each digit represents, let the numbers be. So how are we going to represent that 55%? This is just me. You could do it a little differently, but I usually go 01 to 55. That's going to represent heads. And so then that would mean 56 to 99. Okay, but I also need that 100th one. So that's and 00 equals tails. Okay, and then remember that with the two digits, see, to represent 1 as two-digit, it was 01. Okay. All right. Use a random number table. Start here, please. So use the random number table below and start at the top left corner. All right. A trial consists of, what do you ignore? Okay, yeah, because we hadn't really talked about, is there anything we need to ignore yet? So let's think about this. Because we had two things that we were ignoring in the previous problem. In the previous problem, we ignored the digit 0 because we just had 9 people. Okay, and we also ignored repeats because every time we picked a person, they were not in the running again to go on the trip. Okay, so let's talk about this. So first of all, what does a trial consist of? How do I know I've accomplished what I'm supposed to be doing? Examples are, a trial consists of, select 3 people, flip the coin 4 times, check 5 cereal boxes, a set number of situations. So what do we have here? I think we have this situation where we're flipping the coin 4 times. So a trial consists of flipping the coin 4 times. Okay. Do we need to ignore any two-digit numbers? Okay, I think I have them all accounted for, 01 to 55. Yes, I have 100% of digits represented, or two-digit numbers. So I don't think we need to ignore any digits. And then also think about repeats. And so that's like saying, if down here below when I'm picking my 4 coins, I've got 12, and then I have 12 again. Okay, so if I toss the coin and that represents the next 2-digit number, and that's 12, then I toss the coin again and that's the next 2-digit number, 12. Okay, if I have that, is that okay? And why is that okay? Okay, so let's think about that. Is it okay to have repeated numbers? Each 2-digit number. So, for example, here's a 2-digit number. That's the number 49. What does that represent? Or is that heads or tails? Okay, I think that one is the heads. Okay, 56, that's the one that's tails. Okay, 31, see, I can go across that break. 31, that's a heads. And then 28, that's tails. Okay, now I'm done. That's the end of the trial because I have done 4 coins. Okay, so I got heads, tails. No, that's wrong. I did that wrong here. I believe this is not. I think it's heads, tails, heads, and then heads again, right? You're probably like, what is going on here? Yeah, so that was heads again. All right, so that was one trial. So a trial consists of, now, what happens is, if I had a duplicate number, that's okay. And the reason is, so I usually like to notate that. Repeats are okay because each coin flip is independent of the other coin flips. Each coin flip is independent of the other coin flips. Okay, so then that's how that probability is not changing. It's the same each time. Okay, so what we're going to do is pause and let you continue and running 9 more trials. Here's a 2-digit number, 72, that one is tails, and so on. 14, that's heads. 06 is heads, and then 39 is also heads, and so on, and then I'm done. So I want you to continue to pick 4 sets of 4 coins and do 8 more trials after that, and then we'll talk about the response that we're getting from those. Okay, so pause and then come up with those trials. All right, let's go ahead and do that. I did my rest of my trials, and I feel your pain. That is quite tedious and painful to do. Okay, so we did our trials. Now, let's take a look. A trial consists of, what do you ignore? Your response is critical. What do you look for? So what was it ultimately that we were wondering about in this problem? So you can go back to the question to identify that. We are estimating the probability of finding exactly 2 heads and exactly 2 tails. So that's where our response then comes into play. It's going to be yes or no, did you get what you were looking for? So the response is yes or no to if we got exactly 2 heads and 2 tails. Okay, so hopefully I did mine right, and the ones that I found that had there was one here that had exactly 2 heads and 2 tails. There was one right here, and then one right here. The rest of those were no's. Okay, so you could have written that all along as you went. Okay, so that means that for my statistic, what proportion of times did you get what you were looking for? Well, I got 3 out of those 10 trials. So my statistic is 3 out of 10, which was 30%. So, according to your simulation, about what does this show? Because it's got to have that approximation language in there. So, according to my simulation, I expect to get exactly 2 heads and 2 tails about 30% of the time. All right, and that finishes out that simulation. Okay, so there are 2 that are this estimating the probability simulations. Okay, and so now to finish out this, you're going to do the other one on your own. Okay, so this assignment that gets submitted to Canvas needs to have the 2 notes done of the example that I have here, plus this one here that you have this number 3. And then part 2 of the notes will go through the other 2 of the problems we'll do together, and then the last one you'll do on your own. So that's notes in assignment 1 together, because I wanted to make sure you watched the notes video and such, and then submitted that to Canvas. So that's your first assignment of this next thing. So here we go. I'm just going to leave this one right here. This is one again that you could do theoretically. So I'm going to leave this one here for you and let you try that. And then the notes part 2 will go over problems 4 and 5 and then have you do 6. Okay? All right. So good luck with that.